Hey everyone, and welcome to today's live session. We are thrilled to have you join us. As we give everyone a few moments to settle in and get connected, I want to quickly go over a few housekeeping items. Today's session is being recorded, and we will share the recording with all registrants after the event. We also want this to be an interactive experience, and as our speakers present, you will likely have questions about how these concepts apply to your own engineering environments. So please submit your questions at any time using the chat feature on the screen. All right, great, let's get started. Over the past couple of years, we have all witnessed the rapid advancement of AI models. Agents are automating real engineering tasks, and the potential seems limitless. Yet, as many organizations have discovered, there is a hard truth. Powerful models alone are simply not enough. Without a deep understanding of systems, architecture, and organizational constraints, AI can generate output, but it struggles to operate reliably in real-world, complex environments. So, today, we're going to explore why context has become the critical missing layer in enterprise AI. We will discuss the challenges enterprises face when moving from experimentation to production, and why approaches that rely primarily on retrieving documents of fragments of code often fall short when relationships, dependencies, and constraints matter. To guide us through this discussion and introduce Tabnine's enterprise context engine, I'm joined by two leaders driving the vision here. Please welcome Dror Weiss, co-CEO of Tabnine, who brings a deep expertise in helping organizations navigate major technologically transitions and scale developer tools. Joining him is Eran Yahave, co-CEO of Tabnine. Eran is a pioneer in AI-assisted software development and a professor of computer science, having led Tabnine's technical vision from the earliest days of AI code completion to the agentic systems we see today. So Dror, Eran, thank you guys both for being here. Dror, I'll hand it to you to kick things off.
Hey, thank you, Lee. Good day, everybody. Thanks for taking the time. And as Lee mentioned, please feel free to add questions into the topics you want us to address into the chat. So today we're gonna talk about something incredibly exciting for me, and I think it's in the heart of the biggest transformation in the software development industry, is AI for real-world software development in the enterprise, and how context plays a critical part of it, why it is so important, and how to practically get your AI agents equipped with the right context and the right knowledge to be fully autonomous in when doing tasks for you. And we're gonna go into some cool demos that Eran, my co-founder, will show. But before that, let's talk a little bit about the problem. So when we think about AI today in 2026, the expectations are quite a bit different than what has been 2 and even 1 year ago and even 6 months ago. So AI is no longer a chatbot that answers questions for us that then we process and use the information. AI is no longer the assistant for us that basically gives us suggestions that we can examine and choose whether to adopt or not. AI is, in many cases, it does things for us. In theory, people review it and make a judgment call. In practice, many people do not. And the path to AI manipulating production without human in the loop seems very short today in enterprise. We're not quite there yet in most enterprises and for most use cases, but it is around the corner. Okay, and if we are to give AI the amount of autonomy to really manipulate our production system, we need them to be reliable. Okay, we need them to be as reliable as the people that we trust, as our engineers, because otherwise, if we cannot trust them, they're useless. The autonomy without trust means that you have nothing. So basically, context is all about how do we make our AI agents sufficiently knowledgeable and trustworthy in order for us to give them the keys to generate code for us and push it to production, to fix security issues for us, to investigate performance issues and push fixes and review code for us instead of people, right? We need to really give them high degree of trust. And for this high degree of trust to be possible, we need knowledge. And today, I think the sad realization that most enterprises face with is that the world is not quite there. So agents, AI agents can do incredible things in what we call greenfield applications. When you create a thing from scratch, it's incredible. But when you are faced with a situation where you in a really complex enterprise environment with a lot of moving parts, a lot of services, a lot of deployment and CI/CD, the AI simply doesn't know enough about your system to be effective in a degree that will allow you to be autonomous. And there's been countless study about all the failures of AI in enterprise. I'm not going to bore you with all the statistics. Just saying that, we've seen incredible productivity gains when it comes to creating new things with AI or relatively simple applications. I am personally, doing my things without ever reading or writing the code, some isolated application. That's fantastic. But when you come to real complex enterprise enterprise tasks where it's very nuanced, a lot to know, AI doesn't shine. And I think a good analogy to think of today's AI with the best models, it's like a genius engineer you hire into your organization. But on day one, they know nothing about your system. They are not very efficient, right? Because they need to learn. They need to learn your architecture. They need to learn how's everything connected. They need to know the deployment. Okay, so basically, our barrier from this incredible potential that the models and everything give us to realizing that potential, this gap is the context and the system understanding. And I want to give quick intuition of how we think about the context. So your AI agents operate in your complex system, in your universe, in your world. Okay, and basically, in order to be successful, you can kind of think about it like a map, like knowing how everything is connected, how to go from point A to point B, which roads lead you to that end. And by the way, in order to navigate the map efficiently, you don't necessarily need to know every street. You just need to know the highways. You need to know the things that matter, the things that you should use from getting point A to point B. That doesn't mean knowing every path in the map. So think of like these AI agents as these people in this diagram. Okay, and they need to know certain things about other areas in this building. Okay, and today what they can do in order to find it is to go there, is to fetch all pieces of information and ask questions. Basically, discover the map in the hard way by going everywhere and see where they get stuck. Okay, and what we aim to do in the context engine is basically equip each and every agent or each and every actor in this schema with the full map of everything they need to know. And this will basically avoid them hitting walls and getting into dead ends and getting into danger areas, okay, because they know everything up front and can consult them up. I know this is pretty abstract and high level, and I promise that my dear friend Eran will give you all the level of detail that you'd like, and probably more. So moving a little bit forward, so given that that we need this kind of map, how do we see the modern map of AI stack in big enterprises look like? So there are three big components to it. First is the LLM. Okay, this is the brain of the system. We have incredibly capable LLMs, by the way, both by the frontier labs, accessible through APIs, and self-hosted in somebody's own infrastructure. Secondly, we need the agent that basically uses the LLM to do specific tasks asked by him. This can be agents that are operated by people, okay, and this can be agents that are automated by, simply invoked by automation, all kinds of triggers, CI/CD, event response, whatnot. And these agents basically use the LLMs iteratively in order to complete tasks. This is old news. But really part of the infrastructure on the server side is the context engine. The context engine, we think of it like the oracle that knows everything about the system, and the way these three interact is the agent. Whenever they need to know anything about the system, they go and ask the context engine, who will show you how, already knows all this information and can provide a readily available answers to the agent. And by the way, this context engine, like the entire Tabnine suite, can live entirely on-prem. Okay, so and this is actually very critical for many of our customers, because as we'll show you in a bit, the context engine basically ingests and pulls data from all the enterprise systems of records, from basically from your repositories, but also from your tickets, your production logs, your CI/CD. It basically needs to know everything. And many of our customers say, okay, yeah, I may use an LLM on the cloud, but I really need the context engine who captures the entire architecture of my entire intellectual property to be kind of on-prem or in my VPC, or somehow in the perimeter, in the security parameters that I can strictly control independently. So this is incredibly important for our customers regarding the context engine. This is a key attribute, the ability to deploy anywhere with enterprise-grade security. So we see the stack. The modern stack, you have an LLM. Most people have it like by an external provider, Anthropic, OpenAI, Cohere, Mistral, whatnot. Okay, you have the context engine that also lives in also a server component, but lives in your network typically. And we have the agent that typically runs either on a client, human or human driven, or invokes through an API via an automation. And the combination of these three components gives us the org intelligence that allows us to give a high degree of autonomy to the agent. So how the context engine works in practice? Schematically, it's very simple. It's a server component that ingests all the relevant data from your enterprise. It decode your relevant documentation, your Jira, or any tickets, the support issues you have, and it's able to analyze it and correlate it through context agents that run in the background and continuously update it. And it builds a sophisticated representation, not of the raw material that it ingested, but the things that matter, the things that will be usable for other agents. It builds a representation of the services and the API and the database schema and the libraries that you use, not of the code itself. Why? Because this is what's going to be required and important for the clients, for the task agents that use it. So basically, these task agents are able, or which can be any agent that in the market, like Cloud Code or Cursor, or Tabnine own agent, any agent in the market can work with the context engine and basically ask him to provide specific information, okay, in the form of like a context capsule. Yeah, here's what you need in order to use service X, okay, and you get it and use. And this basically saves a lot of effort and gives the task agent everything they need without them having to recalculate it. And with that, I think it's a good segue to pause for any question and hand over to Eran.
Yeah, thank you, Dror. Well, let's see if something comes up on the chat. All right. All right. All right, so I'll proceed, and if there are any questions on the first part, let me know. All right, so thank you, Chris. All right, so Dror talked about the context engine as a concept. Dror explained how the context engine connects to all the data sources in order to create a structured representation of information in the org. And I'd like to double click and go a little deeper. So the Tabnine context engine is a knowledge layer that learns continuously from all data sources in the organization to create the map of the organization that Dror talked about, to provide agents with deep contextual understanding. So the way it does that is like, first, it basically extracts entities and relationships from both structured and unstructured organizational data. So Dror mentioned connecting to data sources like your source control, like telemetry, like others, and I will show that in a few minutes. But you can also connect to completely unstructured data sources like your Confluence, documentation, design docs, architecture, decisions, records, incident reports, etc. And Tabnine processes that and creates a structured representation that is then available to agents. The second thing that Tabnine context engine does is lightweight skill learning from observing what worked, what failed for past agents. It extracts some skills that can be used by the next round of agentic work. The idea is, again, we have many repeated tasks in an enterprise setting. Many agents have to rediscover things again and again, and the context engine shares that knowledge across the organization. When an agent succeeds performing certain subtasks, it shares that knowledge with other agents to make them more successful. At the end, all of that information is exposed to the task agent, the agents outside the context engine, as application domain structured queries. So this is pretty important. Dror alluded to that. It means that the information that we expose to the task agent is actually at a higher level of abstraction than just the code base or just your Jira ticket or any other raw data. It's something that correlates and aggregates information across systems and surfaces that to the task agent at an abstraction level that makes them more effective. So, for example, rather than reasoning about a specific piece of code, they can reason at the level of services or the level of entities in the database, etc. So when you think about the context engine, this is not a database. It's a system that continuously learns and continuously converts org artifacts into structured data that can be queried by agents and make agents smarter as they use it, and also accumulate information when the agents use it to make all the agents in the organization smarter collectively. And I'd like to switch and show you a little demo here. And let me just start with that.
Hey, Eran, while you bring that up for Dror, there was a question here from Thomas, on how do you combine data sources that live on different systems into a context engine while respecting data safety? Dror, Eran, who wants to take that one?
Yeah, I can take that. We have a permissioning model that respects the permissions of the original systems. Thomas, you're touching on I think a very subtle issue. There are several models that we tried here. Right now, we are using the observability or the authorizations of the original systems, but clearly there are other ways to do this. I think the advantage of what we're doing right now is that at least the user understands why they are not getting access to certain artifacts. But maybe when I dive deeper into the actual context engine and show you some of the things, it will be more clear what do I mean by the boundaries between systems and how we respect that. And if it's not, Thomas, please ask again and I'll double click on that. All right, so I'd like to start with Tabnine CLI here in my demo project. And I'll start with a very simple question, like what services do I have in Acme Commerce? Acme Commerce is my demo application, right? And so what is happening now, you can see that my CLI is hitting the context engine, basically, CX Cloud there. And you can see that I'm getting a response, which is the list of services in my system, API gateway, order service, etc. These are different languages, different architectures owned by different teams, and kind of the purpose for each one of them. And I got that response almost immediately with very
Eran,
few...
just a quick, your screen wasn't showed when you started to the terminal. It was, can you go back and just show the audience what they're using and what question you asked again? Because that wasn't showed.
It wasn't shown. All right, sorry, apologies, friends. I just went into the Tabnine CLI and asked, like, what services do I have in Acme Commerce, which is my demo organization. And what I got back is a table of the services that I have in the system. And that happened very, very quickly and with a very low amount of tokens, because it's not that this agent that I'm running now had to rediscover all that information. In fact, this information lives in 1, 2, 3, 4, I don't remember, 7 or 8 different repositories across the organization. But what the context engine did for me, it built this map, the higher level map of the services, etc., that allows me to get this high level navigation without having to go and rediscover that from the code base itself every time. And now let me do something else, like what can you tell me about payment service? And let's wait for that to come back. You can see it is using, again, the context engine in order to answer those questions. It says, okay, listen, here's the ownership of the payment service. Here's the architecture. It depends on this service and other services. The order service depends on it. It participates in the checkout flow, etc., etc. And you can see there are several past incidents and some active Jira issues that are going on for this service. And now let me try something like, okay, looks like this service is down. What should I do? And again, while this is running, note here that I'm basically getting from the context engine information across the code bases, the deployment, Jira, past incident, etc. And what I'm getting here is like, okay, here's what you should do if payment service looks to be down. Escalate it immediately. This is how you contact the team, and just follow this runbook here. You should check Stripe. You should do the following Kubernetes operations to see what is the status of the various pods. And actually, maybe this is actually related to an active Stripe SDK migration that is running right now, and there's a pull request for that. So maybe you should check that. So it's okay. I think what I want to do is alert the team. Right, and if I ask it to alert the team, it's okay. Right, it can also basically phrase the message to be sent on Slack, and basically my Slack is not connected, and basically do that, right? So it will just say, okay, here's like the message you should send, and this is all the information that I have, and this is like gets sent to the team immediately. So just to recap here, what I did was use Tabnine CLI, an agent that is connected to the context engine as a backend. And what the context engine allowed me to do was to operate at a high level across systems, across information, different kinds of information, and understand how to deal with a potential incident. So I started again just by trying to navigate the org, went into details of a particular service, and at the end kind of simulated what should I do in case this service is down, what is the escalation path, what are the potential issues that led to that, etc., all the way to alerting the team. And the thing here, what I showed you a human using this, but in reality, the expectation is often this will not be used by a human, this will be used by an agent, like an incident response agent, trying to understand how to deal with kind of a system going down. And this is part of what the context engine is able to do completely automatically as well. Happy to take questions here before we dive deeper. All right, so let me share my other screen here and explain. Maybe this will help the question that we had from Thomas as well. Okay, hopefully you can see my screen. I'm yet to understand exactly the delay there. All right. So what you see here is the context engine with representation of the system that we just reasoned about in the CLI, right? And you can see the various entities that we're dealing with. You can see the payment service, which is the service that we started talking about, right? You see other services here, like the notification service, the order service, etc. You can see the different repositories that are connected to it. So note here the connection between deployed services and the actual repositories that they come from. You see the dependencies between the different services. You can see different packages that are used by the services, and all the way to things like vulnerabilities. And the beautiful thing here is that all these little pieces of information, the repositories, the services, the packages, the vulnerabilities, are actually coming from completely different systems. In this case, the artifacts are coming from JFrog Artifactory. The CVEs are coming from JFrog X-Ray. The repositories are from GitHub. And you can see basically this correlated, aggregated picture of the organization across those systems. So now to go back to, go ahead, sorry.
Yeah, I think I just wanted to think it's an attempt to basically mimic the understanding that lives in the brains of senior engineers. This is like an institutional knowledge in complex system. No single person knows all that alone, but basically have both the full breadth of the system, know every service, what they are, how they connect to each other, but also some level of depth to each service. Okay, what are the libraries? What are the vulnerabilities? So that's an attempt, and it's by no means ended, to basically capture all the institutional knowledge that's relevant in a big organization into one single system. So this is what we're actually doing it, because this knowledge is required for agents that are very smart. So we provide them with that knowledge to succeed.
Yeah, thanks, Dror. I think like some things to note here. First of all, it makes certain primitives very easy to implement. Like, for example, if you'd like to know a new vulnerability landed, which services are affected, this is now a trivial question to answer because you have the map that allows you to navigate, the graph and say, oh, this vulnerability, here are the things that are affected, these services that are connected to it. And I don't think I will show that because it's a kind of complicated query, but you can get the idea, right? So Dror alluded to it as well. These are just part of the entities, right, that you need to have in the brain of the senior engineer. There are many other kinds of entities that are present here, including things that come from Jira, things that come from Confluence, other entities, etc. Will not go into all of these. What I do want to show you is the richness of the data sources that you can connect to the context engine. So the way the context engine works is that it connects to all these data sources of various kinds and pull structured and unstructured information into the common unified graph representation, which makes it then available to agents to use, right? So I just showed you like the knowledge graph, which is the fundamental kind of, call it the map that Dror mentioned earlier. And this map is built piece by piece by connecting to different kinds of data sources, starting for source control, issue tracking, documentation, CI/CD, monitoring. So you have the full coverage of the SDLC going from design all the way to deployment and monitoring of what is happening in production. And all that source of information, all that signals are basically organized into part of the presentation is a knowledge graph that allows us to navigate this both as humans and as agents. So I hope this explains at least the fundamental components here. Dror, do you have any questions that you'd like me to cover here before we proceed? You're on mute.
Yeah. So I think it will be useful to go through, okay, this is incredibly comprehensive set of data. To what kind of use cases and tasks it is helpful? I guess many of them, but can you give a few examples of flavors of things that it can be useful for?
Yeah, absolutely. So I think part of like my favorite ones right now, I mean, it's very rich, as you know, it supports many use cases. Part of my favorites right now are incident response, which is the one I kind of started talking about. The second one is recovery or remediation of security issues and trying to understand, for example, firmware vulnerability, how to prioritize which vulnerabilities should be addressed, how to address them, etc. I can show maybe some of that. Other that is any operation that you would like to do across repositories, like refactoring, keeping multiple repositories or system information in mind. And generally, I think providing agents with design document awareness or ticket awareness like Jira as they're operating in the org, right? So I think these are kind of the things that come to mind at a high level. I'm happy to kind of for you to mention others.
Yeah, I think this is all great and correct, and I think in a complex system with many services, basically everything that you do will benefit from the context engine. Like, yes, people here expect our care about incident response, but I assume many people here are also, creating software, creating and deploying. And I think the context engine also helps, like with the common use case. Yes, I need to create some application for me. But if I have the context engine, suddenly my agent knows all the microservices in my system, knows how to find them, knows how to use them because it's in it already. Okay, so I can start basically with a repository from scratch. Okay, but still my agent knows everything about my system, knows my database structure. And if I tell my agents, hey, read all the employee data, okay, it can say, oh yeah, I know how to do that because there's a service for reading employee data, and I know how to use it. Or conversely, I know where the database for the employees is, and I know what's the schema, and I know how to address it, right? So basically, once you connect your context engine, your agent knows your system instantly. And maybe this is a segue around to kind of touch of how agents, how can agents really use this? I think it's very clear that there's a lot of information and power in there, but what does it take for a coding agent to really be able to leverage this?
Yeah, so that's a great question, Dror. Thank you. I think that the way that the context engine works is that it exposes basically tools and skills that external task agents can use. So for example, the one that we used before, I think was find services. I think it was find services or something like that. Let's see, maybe it doesn't exist here. I don't know. I think it was maybe list services or something like that. Anyway,
List services.
Yeah, list services. So that's like, this is a tool that is exposed for the use of external task agents, and the way that it is defined is internally in the context engine as a built-in tool that exposes information as traversals over the knowledge graph. And you can see there are many kind of tools, or more generally skills, that are being exposed by the context engine for the use of external agents. These, you can think of those as macros of useful things for task agents to navigate the map, but the external agents can always revert to using low-level primitives of just walking edges and relationships and entities in the graph itself. Does that make sense?
Yeah, thank you. So I think I making an educated guess that if the agent that you use for coding is the Tabnine CLI, then everything is sort of pre-wired to the context engine, and you have everything out of the box. But many people use also other popular agents in the market. So, like, can you explain, if I'm using, let's say, a Cloud Code or Cursor, what does it take for me to integrate to the Tabnine context engine? I mean, you mentioned skill, but how do I find this skill? How do I sort of integrate it into my agent?
Yeah, so there are plugins for the various agents out there, but the simplest thing that you can do right now without installing any additional piece of software is to connect to the context engine as an MCP server, right? And then what you get is exposing all of those tools, the rich tool set, which you can also define generally in your task agents, in your external task agents. Right, so it's very simple. It's really literally adding 4 lines in your JSON configuration file in order to start using context engine as a backend, and then basically configuring the context engine to connect to your data sources. Right, it could be like, as I said, Jira or GitHub, or in this case, various JFrog systems. And you saw the kind of very rich list of systems that we can connect to. I wanted to cover a few more. Go ahead.
So just to make sure I understand, I think Lee wants to add something. But just to understand, so there are 2 ways to integrate with the context engine. One through skills, and the other directly through the tools, right? These are the 2
correct.
The 2 ways. Okay. Thank you.
Lee, go ahead.
Yeah, I just wanted to drop a question in from Claire. What if one of our engineer tools that would be useful to add into context is not on the list of connections? Is it a feature request or a custom?
No, you can connect to anything that has an MCP server, so you can create your own connection. And it's very easy to add connectors even to your native systems. So that's not a feature request. There's a custom way for you at the user level to define that, right? And I did not touch at all on the agents that are kind of like the worker ants that are creating the various representations, but to go on, I'm guessing Claire's follow-up question would be, once I connect to the data source, how do I reflect those custom data sources in the knowledge graph in the system? And the way to do that is just to also create your own ingester agents, which again is not a feature request, is something that you can do as a user.
Yeah, I do have her follow-up question. In fact, it is, can we separate context per Tabnine team?
You can have different workspaces. So a workspace is a collection of data sources. So you can maintain different workspaces, and you can, the relationship between team and workspaces is many to many. So, a team can look at multiple workspaces, and multiple workspaces can belong to a team. Yeah.
Great questions, Claire. And we have another one from Thomas. We'll just drop this in now while we're on a roll here. One of the bigger problems is that a lot of legacy knowledge, implementation details for a particular piece of code lives somewhere, usually in a senior developer's brain. And if we're lucky, they shared it on a Slack once upon a time. So we're kind of looking for an integrated super search across systems, but with more specific results.
Yeah, so that's a great question. Everything that you reflect in the knowledge graph generally becomes semantically searchable, right? So you can see, okay, hang on, I'm looking for payment, and let me look just for the services. So I found the payment service, and if I want to go, like, I can basically go to the payment service and get all the information that I have about the payment service, right? Including basically some sort of, you can think of that as like a deep wiki with automatically generated artifacts, the relationship between that and the others, etc. So just to, that's a pretty deep graph here. But just to answer your question, it means that everything that you connect immediately becomes searchable, include the relationship between the various things, even from different systems, etc., etc. So I hope that answers it. I think maybe Slack is not the first data source that I would start with. I'm not sure that, in terms, you mentioned permissions or privacy earlier, so maybe Slack is not the first one, but definitely things like Confluence and Notion, other data sources immediately become available to you. And of course, all code is also searchable across workspaces, across everywhere.
Great. One other question that I think we can address right now. How is this different to connecting via MCP? What does the context engine add over that?
Yeah, that's like a great question. MCP gives you raw data. Context engine gives you reasoning at a higher level of abstraction, right? So what context engine does the homework of ingesting kind of the raw data and turning that into a higher level abstraction that the agent can use. So you can think about the context engine as defining the universe in which agents operate, and MCP is just giving you access basically to source of information.
Great. One more, and then I'll let you get back to it. Given the context engine is providing context, does this lower the token consumption during agent tasks?
Yeah, absolutely. Depending obviously on the task, and just like if you consider just the demo that I showed earlier when I was reasoning about services, you can do similar things about vulnerabilities or incidents, stuff like that. The homework that the context engine did upfront and creating a higher level abstraction obviously lets it run more efficiently rather than having to rediscover things again and again from the code itself. It can just work on these higher level abstractions, right, that are reusable. But any agent, for example, that is trying to discover something with vulnerabilities, you don't have to scan the code again in order to discover the relationship between the vulnerability and the service or the repository in which they reside. All of that is available to you because you pre-computed it. So one of the principles of the context engine is doing pre-computation instead of recomputation. And of course, the magic is doing that at the right level of abstraction. So you get something, an abstraction or persistent presentation that is durable and not something that you have to update on every minor change to the system, right? So think of it as building a highway map of the universe and not trying to kind of go and build the narrow street level of the universe, because that is not scalable and has to be have to pay, to go back to your original question, have to pay a lot of token just maintaining the representation current. Yeah, any other questions? All right, so maybe one thing we can do is go back to the presentation. If I find it. All right. All right, so what changes? Oh, again, I have to wait for the screen. All right, what changes when agents have org memory? They stop rediscovering stuff. So if you learned how to run tests in a certain project, you don't have to rediscover that. If you know which vulnerabilities are present, you don't have to discover that. You don't repeat your previous mistakes. The knowledge to the question, again, just to bring back the question about knowledge that got lost in Slack or got lost in some old documents that nobody knows how to find. This is something that the context engine makes easily discoverable. And over time, because everything is organized and information is structured and connected and searchable, you basically accumulate intelligence over time rather than losing it when the senior engineer leaves, right? Importantly, the context engine has internal background agents, or what we call context agents, that run all the time and keep the context engine map updated, up to date, and is able to react to external events like incidents or other observability triggered events. But what the context engine does is not an agent orchestration framework. It lets you define the world your agents operate in. And to Claire's question, the context engine is flexible. You can define the entities. You can define how to create these entities from external systems. And you can define how to expose that information to external agents to make them more effective and more efficient. I'll maybe do this very quickly. We don't have a lot of time, but I do want to cover some of the principles that are underlying the context engine. One of them is that systems cannot be reasoned about from fragments, right? You saw the knowledge graph that is aggregating and correlating information across systems. And the idea here is that if you are, for example, trying to review a pull request and you don't understand, what is the environment in which this pull request operates, you don't understand the downstream services, you don't understand the databases that it is impacting. If the agent does not have sufficient context, then the agent is basically guessing what is the environment in which this pull request lives, or the task that it has to perform is taking place. And these guesses lead to basically integration problems later and to incorrect decisions made by agents. And this is exactly where kind of the institutional memory of a senior engineer comes into play when they say, oh, wait, oh, you're touching that. No, that will, downstream going to create problems with the rate limit of the other service, right? So these kind of like relationships or correlation across fragments is what you want to recover in the context engine, kind of capture the mind of the senior engineer, and we kind of saw that in the Graph Explorer. An important thing is like nothing really exists in isolation, right? So looking at the service is by itself is not super insightful, but if you understand how a service is connected downstream to the other services that consumes it, if you understand the deployment frequency, who is the team that is owning it, what are the design decisions that led to it looking like that, you can suddenly reason about, what is the impact of that service going down. You can suddenly reason about like, hey, why is the deployment frequency higher in the last 2 weeks? All those things that we rely on the senior engineers in our organization kind of to keep in their head now becomes explicit as part of the infrastructure, of the context infrastructure that is maintained by the context engine. Skip that, yeah. I think I kind of touched on that when I showed the knowledge graph. The system must be navigable at every altitude. So you, as an engineer debugging something, you don't just look at at the function or at the class or at a package. You typically navigate across different levels. You take the highway map and then the street map to go to the previous kind of intuition. And you need the context engine to be able to do the same, represent the information at different altitudes, such that the agents can take action at the right altitude, get to the right area to perform the task, and then dig deeper. So there's no attempt here, for example, in the context engine, to represent every little piece of code explicitly in the knowledge graph that does not scale. What you want to do is have different scales of presentations for different part of the organizational information, such that agents can operate on them and manipulate them effectively. Right. Another thing that the context engine does is basically listen to external events in order to be current. So it is continuously, I mentioned this earlier, continuously update itself by maintaining connections to these external data sources, be it the source control or observability platform, or if you would like that, to Slack. And basically, you can trigger various agents inside the context engine saying, oh, you know what, if there's a CVE detected in Snake or in JFrog, you should run the CVE auto-resolver, or whenever a pull request is opened, you should react to that by running the code review, or you should do some other things here that automatically triggered in the context engine in order to take action, update the internal model, and also potentially affect or take effect in other external systems. So again, very important that the model must stay live, right? The stale map is worse than no map. It throws your agents in the wrong way. So that's part of the effort of the context engine, keeping a live connection to the external systems. I'll skip that. An important thing also related to Thomas's question about permissions and who can see what and stuff like that is maintaining provenance and confidence across the artifacts that enter the context engines. You want to be able to say, hey, where this piece of information came from and what are the permissions around it, what is the last time that was updated, how fresh is it, and how certain I am that this is actually the right information that I need to perform this task, right? And agents really need to be able to trace this back to the knowledge, to the origin of the knowledge, in order to establish trust that this is the right kind of information and that you can trust it to make decisions. I see Lee coming online, so yeah, Lee.
Yep.
Are you telling me that we're out of time? Or?
We're getting close, but I wanted to drop this one in because some clarity I think is really important here. Can you show me some examples of those learned skills you mentioned in the beginning?
I don't have it like open here, but I can. You can think about it like my favorite is like learning how to run tests in a complicated, nasty enterprise setting. For example, this is a skill that is repeated, I think, across almost any project that I worked on at enterprise scale. Typically requires installing all sorts of dependencies, setting up the mocking, for example, external databases and stuff like that. And it's something that agents discover and rediscover every time again, or someone sits down and writes this manually for each of the projects that they are working on.
Great. I'll let you wrap up.
Yeah, so important thing, like last message, context is infrastructure. This is the foundation that every future generation of agents will depend on, right? In the past, the bottleneck of everything that we're doing was basically writing code. Now the bottleneck is really understanding the systems in which we operate, right? Writing code is really becoming, to a large degree, a non-issue, but understanding where this code lives and how it interacts with other systems is critical. And really, context defines the universe agents operate in, and the better you can define this universe, the better or the higher the benefits that you will get from it. Okay, so that's all I have.
So we are going to drop one more from Thomas. Thank you, Thomas, for your participation. So how's the discoverability of this data when using an agent?
So let me just stop my screen here. How's the discoverability of this data when using an agent? Oh, no. So again, you want the context engine obviously to be always on. You definitely have dynamic discovery of the tools that are required. You cannot keep all these tools in the context all the time. You also have different toolboxes, and you have skills for which tools are being used for each task. But absolutely, Thomas, this is something that you need to address, and we address it as part of the context engine. The richness of the suite of tools does not mean that the agent has to go through all of them for every task that they do, but it does mean that context engine is on all the time, as you phrased it, but it is just using skills in order to understand what to use when.
Yeah, and always on is a good phrasing for that. Love it.
All right, looking at the time, it seems like we're just about at the top of the hour. So I wanted to give a huge thank you to everybody who joined today. The level of engagement and the quality of the questions was really fantastic. So if you didn't get your specific question answered during Q&A, please know that our team has captured it, and we will follow up after with an email. Dror, Eran, again, thank you so much for both sharing your insights today. It's clear that AI moves from pilot to production, having that deep understanding of an organizational system. And the constraints is no longer just a nice to have, it's a critical foundation for operating safely at scale. So for those listening who are dealing with that exact challenge, navigating complex architectures, we would love to show you what this looks like in practice. So we invite you to connect with our team for a personalized one-to-one demo. We can walk you through your specific environment and show you exactly how the enterprise context engine can map your systems and empower your AI agents to reason and operate safely within your unique infrastructure. So down at the bottom, you'll see a link on your screen that you can schedule a session, or you can always reach out to us directly at context.tabnine.com. Thank you again for your time, your questions, and your participation today. Have a great rest of your day, and we look forward to speaking with you all soon.
Thank you.
Thank you all.